Probably my favorite result of functions being continuous is something called the intermediate value theorem. So the intermediate value theorem, in sort of non-mathematical terms, means that if you have something continuously moving and it starts in one place and ends in another, then the function has to attain every value in between those endpoints. Think of it like growing. If you know at some point you were 2 feet tall when you were a child, and you know now you are 6 feet tall as an adult, then if I say, well, at some point you were 3.25 feet tall, you had to have been that exact height, because there's no way that you would have just been like, whoop, and just like grown and not grown some height in between. You would have had to have swelled to that piece. You have to hit that point in the middle. And that's the idea behind the intermediate value theorem. It's just like driving. If I'm driving on a road to get from one place to another, I have to drive on every bit of the road between them. I can't somehow launch my car and land at the other point. It just doesn't work that way. And so formally speaking, what that says is that if f is a continuous function on some closed interval, ab, and that the function outputs at the endpoints don't equal each other, and also you have to say the interval is non-empty. This, you don't have to, but anyway, if you could say that, then if there's some number that's between the value at those endpoints, then and it could be that if f of a is smaller than f of b, that's one way. The other way is, right, it could be the case where this value is higher than that value, or otherwise could be going up or down. Doesn't matter. But the point being is, if there's some value between these 2 points, then I can always find a point in between the endpoints that it has to go through. I challenge you, draw any continuous function you want to hit, no matter what. If you take these points here and draw some line through the middle, the graph has to strike it there. And that's the heart of the intermediate value theorem. It's a really, really powerful result that we're going to leverage later when we're talking about some interesting results in calculus, but it's incredible.